Hello, this is our second example for that Pearson correlation. So it's a very similar situation, scenario. The only difference is we have a different number of inspections and accidents that we're now testing. So exact same scenario, what type of test. It's still a correlation, and actually I guess I should be more specific, Pearson correlation, because it is a measure. We're looking at that measure of strength and direction of a linear relationship, and we have paired numeric data. Once again, that hypothesis, very important, that there's no relationship, that there is a relationship. So null, always the no relationship. An alternative is that there is a relationship. We're then going to run the statistical test using JASP. So let's go ahead and copy this information and bring that over there. Sorry, I didn't get it sized. There we go. So new data and paste. All right, then always double check. Okay, we've got 12 and 12, 80, 172, 20, 181. Okay, yep, we look good to go. But you always want to double check. This is scale data. This is scale data. Make sure to save your data. So make sure to go to your computer, save your data. And cancel. And then we can go ahead and go to the analysis. Now remember, we're going to regression, correlation. We're going to go ahead and add both of our variables. We do want that Pearson's R. We want to display pairwise. We want to report significance, flag significant correlations. We want the sample size. We love that scatter plot. And then remember, for assumption checks, we want that pairwise normality. Okay, so now that we have this information, remember we're going to copy all of it over, so we're going to use that snipping tool. Remember, snipping tool on all PCs, just start typing snipping tool in the search bar, it'll come up. If you have a Mac, use something else, but we want to make sure that we are snipping these, and then we also want to make sure we snip that scatter plot. So now that we have all of the data, and if it feels like I'm moving a little faster, it's just because this is the second example. So if you need to kind of go back and get a little bit more detail, go back to that first example where I do a little bit more talking through all of this. So in this one, I'm assuming that you've already watched that first example. Okay, so review statistical results, and these are the statistical results, and you can see I already added a little bit of notes here. So first of all, we're going to interpret that Shapiro-Wilks p-value, and remember, Shapiro-Wilks checks for pairwise normality of the data. In this case, we want a high p-value. Our p-value in this case is less than 0.05. That means our data is not normally distributed. So boo, it does not follow that normal bell curve. It is not normally distributed. Also note, if you don't have enough data, Shapiro-Wilk will not calculate. That's okay. Go back to example 1. I show how to deal with that. But if you do have Shapiro-Wilk calculated and it's not normally distributed, what you need to do is basically, so if that p-value is low, you cross out, you do not need the Pearson correlation because the data is not appropriate to use for the Pearson correlation. So if this p-value is less than 0.05, Pearson correlation is not appropriate to use with this data. Instead, you're going to go ahead and switch to Spearman. And now it's super easy to switch to Spearman. If you want the full Spearman talk through, watch the next video series on the Spearman correlation. But all you have to do to switch to a Spearman is just check this box and uncheck that one. And now you have, not right there, now you have the Spearman correlation information. And then this was the one that I then went ahead and I copied that using that snagging snippet tool. And here is our new updated Spearman correlation information. So remember, if that p-value is too low, correlation, Pearson correlation is not appropriate, you have to run the Spearman. Now for the Spearman, you interpret it very, very similar to the regular Pearson correlation. So once again, this p-value, if that p-value is less than 0.05, which it is, we're going to reject the null. So yay, we get to reject the null. That means we do have significant results. So we have significant results because this p-value is less than 0.05. That means we can reject the null. Then we're going to look at how to interpret this Spearman's R, or Spearman's rho, and it's exact same as that correlation coefficient for Pearson. So we have a negative 0.744. That negative and 0.744 does fall into the strong negative. So we do still have a strong negative correlation. It's just a strong negative Spearman's correlation. Degrees of freedom is also the exact same as the regular correlation. So it's just 12 minus 2, 12 being that sample size, minus 2 equals 10. Okay, so how do we write this up? So remember, this is where the Shapiro-Wilk was significant. So a Pearson correlation, because initially we were trying to do the Pearson correlation. So you do start it by saying a Pearson correlation was conducted to determine if there was a relationship between the number of inspections and accidents. That's going to be still your null alternative hypothesis. Shapiro-Wilk showed significant results. So we've got our P, make sure to italicize it, no leading zero, then 0.046, indicating the data was not normally distributed. Because of this, it's recommended that a Spearman correlation be done to account for the departure from normality. So then you do the write-up for a Spearman. So this is how it's different from that first example. So a Spearman rank order correlation was done to assess the relationship between the number of inspections and accidents. It was determined that there is a significant negative relationship between inspections and accidents. Very important. You now have the R and the little subscript S because it is a Spearman. Still the same 10 degrees of freedom, no leading zero, but you've got your coefficient, your correlation coefficient for the Spearman, and then you've got your p-value. Make sure to italicize important statistical letters. Do not use leading zeros. Need to make sure you say that the null hypothesis was rejected. So very important. You need to say that it was a significant relationship. You need to say the null was rejected. The Spearman coefficient indicated a strong negative relationship between inspections and accidents. When the number of inspections goes down, when the number of inspections goes up, the number of accidents goes down. And then, of course, you can always see that right here. And this is why it's so wonderful to do this plot right here, doing this little plot, this scatter plot, because it will show you exactly what, we found here at the end. So this is that second example. I hope this helps. And if you have any questions, let me know.